Hey guys, welcome back to the clamp knurling tool project tutorial. Apologize for taking so long to get back to the project, but we had the plague run rampant through the family, and pretty much everybody got sick, including the dog. I was last in line, so I'm just now getting my energy back to get back to business. So let's get to it here. I'd like to take first of all, I'd like to dedicate this video to sort of a trial run on my new audio equipment. I've had a lot of concerns and comments about how hard it is to hear my voice over some of the machine noise and the shop noise. So I invested some of my website donations and bought a wireless microphone and also a digital audio recorder. So now I can record my voice on its own track, and I can record all the other shop noises on two other tracks on stereo, and so I can control the level of my voice over the background noise. So we got machine noise going, we got a heater going up above, we got the silly phase converter making all kinds of racket in the background. We should still be able to hear my voice. So let's try it out. Let's switch over to the new audio system and see how it works. All right, we should be switched over. You should hear my voice a lot clearer now over the wireless mic, and you should hear a lot less of the machine noise and the background shop noise. So hopefully that'll work out better for you, and you'll be able to hear what I have to say. So let's get busy here. I think this video we have some counterbore holes to put in the body. We have some tapped holes for a set screw for locking the knurl holders down, and we also have some cuts to make on the outer contour of the body to give it the shape. So let's get busy. Alright, so I'm looking at the drawing here. I was getting ready to drill some holes, but I think I've had second thoughts. I think I'm going to stop and make these outside milled cuts on the body, establish the shape first. And the reason is, if you look at these two set screw holes here, these 5/16 18 holes, there's a spot face on them to make them full diameter because they're on this angled surface. So the note says spot face to 380 diameter to full diameter. To do that, we need to have the angled surface first, so we know how deep to spot face. So instead of doing the holes now, I'm going to stop and I'm going to do these cuts on the outside. And I'm also going to show you 4 different ways to make these cuts. Okay. So that way, depending on what type of machinery you have or tools you have, you'll have a good way of doing it. So first of all, what I need to do is scribe some layout lines on the part and bandsaw these corners off, regardless of what method I use to make the final cut. First thing I want to do is remove as much metal as possible. So let's lay it out and saw those corners off. I don't know if you can see that or not, but first thing I'm going to do is put a scribe line 2.280 from the end. And then I'm just going to set my protractor for 25 degrees and just scribe an unangled line 4 places. You can use a height gauge and a surface plate to do this 2.28, or you can use your dial calipers, or you can use it's only a 2-place decimal, so you can use a combination square if you want. It's not very high tolerance. So there's 2.28. So let's just put a little mark in 4 places so I know where to draw that 25-degree angle. If you have some layout die, you can throw some on, or I like to use a magic marker, or this is pretty easy to see. And we'll draw a 25-degree angled line up to that point. Nothing real critical about this. I'm just going to remove as much of the extra material as possible so we don't have to mill so much. It's a lot faster sawing than it is milling. Whoop, that doesn't look right. Wait a minute here. 25, not 15. That's more like it. Okay, got 4 angled lines. Now let's move over to the bandsaw and cut the corners off. Okay, so let's use a little wax on this aluminum. Helps keep the blade from, or makes the blade cut a lot better. And I'm going to stay away from this line about, oh, I don't know, 1/16 of an inch maybe. Cutting speed should be about 500 for this, for aluminum. This blade's starting to get a little dull. This is the same blade I made up in my blade welding or blade soldering video over a year ago. So it's served me pretty well. Okay, that'll make it a lot easier to mill. Let's move over to the mill and make it pretty. Okay, the first method I'm going to use for milling these angled surfaces, I'm just going to use a couple parallels on the vise, stack them up, and then I'm just going to eyeball this scribed line I put on there. So it's lined up with the parallels, okay? So you can get a light down and get your machine light down in front of it so you can see the line real well, and then you can just pretty easily adjust it until the line is parallel with the top of the parallel. Then lock it down. Okay? So you're just using your parallels to line up the part in the vise. This is a low tolerance cut on here. It's pretty much just for aesthetics, so we don't have to be too careful about getting the angle just right, or the location as far as that goes. Location's a 2-place decimal, and as is the angle. So this is plenty close for this situation. So now we can just go ahead and take a cut on it with a fly cutter till the cutter cuts down to our scribed line we put on, and we're done. So let's go ahead and do that. Zoom in a little bit so you can see what's going on a little better. Okay, literally just raising the table a little bit at a time until the cutter breaks the line, splits the line, I should say. When that happens, we're done. Okay, that's one way. Second way, now that we've established a good angle already, let me take the burr off. Knock the burrs off it. Okay, so now we have one angle done. So we can use that angle to locate the cut opposite of it. So we'll just set it on the bottom of the vise, lock it down, and machine down to our line. All we're doing is copying the first angle that we established. And that'll save you some time of setting up a second one. Okay, so that's two sides. For the third side, all I'm going to do is I'm going to step over to the belt sander, and I'm going to belt sand this side here to the line, okay, freehand. That's another quick and dirty way that you can make cuts on a part like this for aesthetics. So let's go ahead and do that. Okay, so let's belt sand one of these edges to size. Takes care of three of our edges. I could have sawed that a little closer. It wouldn't have taken so long to bandsaw it, but that's three methods. And the last one is going to be a sine bar. Okay, I know it doesn't. Sine bar is meant for precise angles, but I'd like to use it on this just to show you how to set up and use one. So let's go ahead and do that. Back to the milling machine. Okay, sine bar is a neat little device for setting up very precise angles. What it represents is the hypotenuse in a right triangle. If you have a triangle that's has a 90-degree corner to it, okay, the hypotenuse represents, or the sine bar represents the long side of that triangle, or the hypotenuse. Okay? And with trigonometry and right triangles, if you happen to know any two parts of this triangle, you can use those to calculate a third part. Okay. In this case, we want to set this sine bar for 25 degrees. So we're going to call this angle of the triangle 25 degrees. So we know that angle. We know the length of the hypotenuse. In this case, it's 2.5 inches. This is a 2.5 inch sine bar. The rolls are exactly 2.5 inches apart, or very close to 2.5 inches. So we know the hypotenuse is 2.5. So since we know this angle and the hypotenuse, we can calculate how big of a stack of gauge blocks, or how far this left side of this sine bar needs to be raised up. Okay, we'll call that x. Okay. So for I know you can look up a chart in Machinery's Handbook. There's a sine chart in there for sine bars. I don't know if there's one for a 2.5 inch sine bar, but there's definitely one for a 5 inch. All you have to do is divide by 2. But so you can look up there, but I like to show the why behind some of this stuff, so I'm going to show you how to calculate it using trig, how to calculate the height of the gauge blocks using trig. So let's see here. We're going to be using the sine function. Okay, so the sine of 25 degrees in this case, sine of this angle that we know, is equal to the opposite side of the triangle, the side opposite the angle, in this case is x, divided by the hypotenuse. In this case, it's 2.5. All right? So that's the trig part. Now we have to solve for x. So we have to switch gears and use a little bit of algebra. Okay? So since the 2.5 inches in the denominator on this side of the equation, we have to multiply both sides by 2.5 to get rid of this fraction, okay, and isolate x. So let's do that. Let's multiply each side of the equation by 2.5. 2.5 times the sine of 25 equals x. Okay, that's a little easier to figure out. We can look up, we can use a calculator to get the sine of 25. Okay, it is, if you can see that, 0.4226. So 2.5 times 0.4226 equals x. Remember, x is the height of the gauge blocks we're looking for. So working that out gives us 1.0565. 1.0565 equals x. Okay? So that's a stack of gauge blocks we need to build up. Now I do have a video out on gauge blocks. I show how to build a stack, so I'm just going to kind of go through it quickly here. Basically, you start from the right-hand side of the number. Okay, we need a gauge block that ends in this case 5/10,000ths of an inch. So the closest one in the set that I have, in most sets, is 0.1005. So we'll pick that gauge block, then we'll subtract that one from the number. 0.1005. It gives us a 0 there. It gives us a 6. It gives us a 5. And let's see, 9, 10, 0.956. Excuse my writing. I'm trying to stay out of your way. All right, so now we got to get rid of this 6. The next one in the set that ends in a 6,000ths is 0.106. So 0.106 subtract gives us 5.850. Okay, and the next one in the set that matches this number is 0.850. So those three blocks equals 1.0565. So let's go ahead and ring these babies together. Always clean them off. Whoops. Try not to drop them on the floor. Clean them off on your wrist, and then you just start with a corner like this and push them together. Push them and turn them together, okay? And they'll stick. Wiping them on your wrist like that gets all the grease and oil off that one didn't stick, from storage and dust. so it doesn't damage the block when you ring them together. There we go, that's better, that's stuck. Okay, so now we have our stack of gauge blocks. We set the sine bar on this stack. That tells us this angle of the sine bar is 25 degrees. So now we can put that to use. Okay, now set the sine bar in the vise, put our stack of gauge blocks under one end of it. That gives us a 25-degree angle. Let's see, let me grab a parallel here. Okay, now we can put our part in it with the last edge, unfinished edge pointing up. The sine bar is a little bit wider than the part, so I have to use a parallel to make up the difference. Whoops. All right. Fumble fingers here today. All right. Okay. All right, that looks pretty good. Let's go ahead and take a cut on it. This part's kind of sticking out a ways, so you have to be a little bit careful. Not take too heavy of a cut. Well, this is a really good way to get a nice, precise angle. Okay? Overkill for this project, but I thought it might be fun just to show you another way to mill an angle. So that takes care of all these sides. The next video, I'll go ahead and do all the holes. Now that we have these angled surfaces, we can tell how deep to spot face those two set screw holes. So I'll see you then.